Morning, students. Let us start the today's session. Topic is elementary signals. And myself, Vijay Shankarian from Electronics and Communication Engineering Department, Chevrolet Engineering College. And in the previous class, we completed the classification of signals, and now it is elementary signals. Elementary signals. So what are the elementary signals? Elementary signals is also called as a standard signals, unit step function, unit ramp function, unit impulse function, unit parabolic function, exponential function with the real and complex and sinusoidal function, and also the signum function. Coming to the first one, the unit step function. The step function is an important signal used for analysis of many systems. The step function is that they are elementary function which exists only for positive time and zero for negative time. Means it having only the positive time and there is no any negative values, and its magnitude is unity, is called unit step function. Again, I am saying, my dear students, a step function is that a type of elementary function which exists only for positive time and is zero for negative time. And if a step function has unity magnitude, then it is called unit step function. Okay. And the usefulness of the unit step function lies in the fact that if you want a signal to start at t is equal to 0, so that it may have a value of 0 for t is less than 0, we only need to multiply the given signal with the unit step function, the mu of t. So for the continuous time, the unit step function mu of t in the mathematical expression, mu of t is equal to 1 for t is greater than or equal to 0, and 0 for t less than the 0. Okay. And the mu of t is the signal. If you can shift the signal with a sample of A, we can write as a mu of t minus A is equal to 1 for t is greater than or equal to A, and 0 for t is less than A. Means shifting the sample towards the right side, we can call it as a delay function. Shifting the sample towards the left side as advanced function. What is the right and what is the left means? The reference is at the origin. Means that t is equal to 0. If t is equal to 0 is a reference, the sample is shifted with the A samples, and the sample shifted the A samples towards the right side, or it is a left side. A right side means the mu of t minus A is equal to 1 because the step function has unity magnitude. For t is greater than or equal to A, and 0 for t is less than A. Okay. Now, these are the two equations for the step function, and the step function is delayed with or the shifted unit step function with an A samples. Coming to the graphical representation, you see here at the reference of at t is equal to 0, it having only the positive values, there is no any negative functions. So the definition saying that the step function is that a type of elementary function which exists only for positive time and is zero for negative time. Okay. So only for the positive time, there is no any negative time. The negative for all the values of t, the negative values of t is a 0, and all the values of positive values of t, the magnitude is 1. The second characteristic is what's shown in this slide. It is a shifting of a samples. The step function is shifting with the a sample. Whatever the a is there, that a is either 1, 2, or so on. And is shifted towards the right side, means it is a delay function. As a reference of at t is equal to 0 here, and it is shifted towards the right side with the a samples, we can write it as a mu of t minus a. Either a is 1, 2, 3, and so on. If 1 is there, we can shift 1 sample. If 2 is there, we can shift the 2 samples. Okay. And similar fashion, it can be represented, the unit step function in the discrete time. The discrete time unit step sequence mu of n is defined as mu of n is equal to 1 for n is greater than or equal to 0, and 0 for n is less than 0. In the shifted version of the discrete time unit step function mu of n minus k. In the discrete, in the continuous, we are using the mu of t minus a, and now I am using here mu of n minus k. Is defined as mu of n minus k is equal to 1 is a magnitude for n is greater than or equal to k. From k onwards, it is a magnitude is 1, and for k less than, the magnitude is a 0. Now it's shown in the graphical representation of the discrete unit step sequence. You see here, from n is equal to 0 to the so on the n values for every instant. At 0 is 1. When n is equal to 1, the magnitude is 1. When n is equal to 2, the mu of n is equal to 1. And n is equal to 3. For all the values of n, the mu of n is equal to 1. But graphical representation is in the discrete. Come to see here the second discrete time b, the shifted unit step function. It shifted the k samples. Mu of n minus k, that k or k plus 1, k plus 2, k plus 3, and so on, the values, the magnitude of mu of n minus k is the same. Means shifting towards the right side, we can call it as a delay function. How I will explain it is, see, so I'm drawing one function here, x of t function. Let x of t is equal to, as a unit step function, as a t, see, not the x of t, you can write as without confusion, put it this as mu of t, because it's a step function denoted by the mu of t, and 0 for continuous time function. Graphical representation of a step function is like this. Okay, the magnitude is 1. I'm taking it as a continuous function. Now, the shifting with the say 1 sample. Shifting of one sample. If I take like this, mu of t minus 1 means it shifted 1 sample ahead and starts the characteristics is like this. Here the magnitude is 1. Here the magnitude is a 1. The x-axis is same as the t. Similarly, if it is shifted with two samples means the reference value is 0 here. You can write as a mu t minus 2. Two samples. See, one sample is here and it starts at the second sample. The second sample means shifted with the two samples. Here it is a 0 and at the 0 also it is a 0. And here the 0 is equal to 0. And so on. We can call these as a delay functions. Delay. Okay. And what is the advanced functions? Advanced function means it's a reference if I am taking the same thing, the step function is a step function. Okay. Now I'm taking the advanced function. Advanced function means the signal denoted as a mu of t plus 1. Okay, t plus 1 with the samples of the t. I'm saying it is advanced. The reference you can take it is a 0 here. Advanced means before it is a 0. Means it starts from the minus 1. The step function. Here the magnitude is the same, 1 only. There is no any change in the magnitude. The magnitude is a 1. Okay. One sample towards the left side. And if I am taking the another advanced signal, mu of t plus 2, now you can see the 0 is a 0, at t is equal to 0, the value is not the 0, sorry, and at minus 1, and this, it starts from the minus 2. Here also the magnitude is 1. Okay, mu of t plus 2 here. So what is the expression? What is the expression you get here? And mu of t plus 1 is equal to as 1 and 0. And 0 for t is less than minus 1. And 1 for t is greater than or equal to minus 1. This is the expression for this. Okay. Now coming to this one, the same thing, mu of t plus 2, is equal to 1. Means always a magnitude, there is no any change in the magnitude, only the shifting operation occurs in the time period only. So I'm shifting the time only. 1 for, what is the value here? The t is greater than or equal to minus 2. Because from minus 2, the value minus 1, 0, 1, 2, 3, and so on, both are the values of the zeros. For 0, less than the minus 2. Less than minus 2. Okay. This is a function for this. We can call this as advanced functions. This value, whatever we are taking the A is changes 1, 2, 3, and so on. If it is a minus A, delay function, minus A is a delay function. Whatever, if I am taking the mu of t minus A as a delay, and here mu of t plus A as advanced function. That A is either 1, 2, 3, and so on. 1 means one sample is shifted. 2 means 2 samples is shifted. If it is a 3 samples is shifted. shifted. And advanced signal, in the advanced signal, I'm taking the t plus 1. T plus 1 means one sample before the 0 it is advanced signal only. One sample is advanced, mu of t plus 2. One sample is, two samples it is advanced, add mu of t plus a, whatever the value is there here, minus of minus 1, minus of minus 2, minus of minus 3. It becomes of the plus 1. Okay. Whenever if it is mu of t minus a, call it as a delay function. Mu of t plus a, call it as a advanced function. Now you can understand how you can shift the samples towards the right side and how you can shift the samples towards the left side. Okay. It is a shifting, linear shifting. Linearly we are shifting. Linear means towards the right side or the towards left side. Circular shift is there, that we'll get in the another unit. Okay, these are unit step function. Mu of t having only the for positive values only, and its magnitude is always a 1, and there is no any values for the negative, that is a 0. Understood, my students? Then coming to the next topic, unit ramp function. Unit ramp function. And before going to the unit ramp function also, we can see this is for continuous function, continuous time function, how the discrete function look like. Discrete time functions. Discrete time. Okay. Now I am taking the discrete time function as a reference of mu of n, mu of n. For 0, the value is 1, magnitude. For 1 also, the magnitude is 1. For 2, the magnitude is 1. For 3, the magnitude is 1. Okay, and so on. Here only the variable is the difference. So discrete time function is represented for every instant of time, not for every instant, for particular instant of time or specific time intervals. At specific time intervals, or it's a particular time instance. For every instant means it is a continuous. It's a discrete. At 0, at 1, and at 2, at 3, we are taking the values. Now coming to the mu of n minus 1. Okay, mu of n minus 1. N minus 1. Whatever in the equation, we are saying the mu of n minus k. Mu of n minus k for n is greater than or equal to k. The value is 1, and 0 for n is less than the k. That k is varies 1, 2, 3, and like that. Mu of n minus 1 is a delay function. How many samples it's delay? 0 is a 0 now. So whatever the samples we have in the mu of n, it is shifted towards the right side. At 1, it starts from the 1. At 1, the value is 1. 2, the value is 1. And for 3 is also the value is 1. Up to so on. Okay. For this, the equation is the mu of n minus 1 is equal to 1 for n is greater than or equal to 1, and 0 for n is less than 1. Okay, my dear students. Now it is only the shifting of one sample only. It is a delay. Delay of one sample. Okay. Now coming to the two samples delay. Two samples delay, mu of n minus 2. Mu of n minus 2 means shifting of two samples right side. The 0 is a 0. 1 is a 0. And it starts from the 2. 1, and 3 is also the magnitude is 1, and 4 is also the magnitude is 1, and so on. All the variables is here the n only. The variable whatever we are using, the n and the n. Now what is the equation we'll get here? The mu of n minus 2. Mu of n minus 2 is equal to, the value is 1 for n is greater than or equal to 2 now, because here the 2 is there. And for this function, and 0 for n is less than the 2. Okay. So see, for the standard step function equation is also, I'm writing this 1 for n is greater than or equal to 0. Because here the 0 is there. N minus 0, n minus 1, n is greater than or equal to 1 here, n minus 2, n is greater than or equal to 2, and 0 for n is less than the 0. Okay, so whatever we are writing the expression as the discrete mu of n minus k as a delay function, that k is varies 1, 2, and so on. So one sample is shifted right side, one sample is shifted right, 2 samples is shifted right side, like that. Coming to the advanced function, for this also the reference is a mu of n only. For advanced function, to see how the graphical representation look like, mu of n plus 1. I'm writing the mu of n plus 1. So it starts from the minus 1, it is minus 1, the value is 1, and 0 is also 1, and 2, the value is 1, and so on. Okay. What is the expression here? We'll get the expression is a mu of n plus 1, mu of n plus 1 is equal to 1 for, what is a 1? It starts from the minus 1. Minus 2 is a 0. Only it is shifted towards the left side. Shifted towards the left side because it is advanced. 0 for n is greater than or equal to minus 1. Whatever the value is there, here you can write this is 1. N is greater than or equal to 0, n is greater than or equal to 1, n is equal to greater than or equal to 2. And because it is a plus, minus of minus 1. Minus of minus 1. So n is greater than or equal to minus 1. And 0 for n is less than the 0. Not the less than the 0, sorry. Less than minus 1. Okay. This is advanced signal. Similarly, if I take another advanced signal with the 2 samples, mu of n plus 2. Now it starts from the minus 2. At minus 2 is a 1, minus 1 is a 1, and 0 is a 1, and 1 is a 1, and 2 is also 1, and so on. The variable of n. Now what is the expression here? Mu of n plus 2, the advanced function, is shifted towards the left side. What is the expression here? Also the magnitude is a 1 for, the value is n is greater than or equal to, it is a minus of minus 2. So minus 2. N is minus 2, and 0 for n is less than minus 2. Now you can get one idea how the continuous time function, you see this is a continuous time function. Advanced signal and the delay signal. Delay means shifting the right side. Advanced means shifting left side. And for the discrete time function, here also the delay and advanced is mu of n plus k. Okay, mu of n plus k is advanced, mu of n minus k is a delay. Delay means shifting. Shifting towards right side. Towards the right side. Following, my dear students. Shifting towards the right side with a given number of samples. One number of sample here, one number of sample, two numbers of samples. Mu of n plus k means shifting towards left side. Left side with one number of samples, two number of samples. The remaining values here is 0, -3, -2, and here also -2, -1. Let it be see that also. -3, here the 0. And here the -2, here it is a 0. The remaining all it is the left hand side is the zeros only. But always the remaining values what we have it is so on the positive values towards the right side, the positive one. Okay, these are reference for the discrete and these are reference for the continuous time. Now we got this idea how we can draw the graphical representation for the step function and the advanced function and the delay function, how it look like with the shifting of one sample, two samples, and three samples in both the continuous time function and discrete time function. Now again, let us go to the next one. Next elementary signal is unit ramp function. Unit ramp function. You know the ramp means when the time is increases, correspondingly the amplitude is also the increases. Means in the y-axis and the x-axis you can see the signal as R of t. R of t is unit ramp function. When t is increases, t is equal to 0, R of t is also 0. T is equal to 1, R of t is also 1. T is equal to 2, R of t is equal to 2. When the time is increases, the R of t is also correspondingly increases. We can say it is a linear function. Okay, linearly increases. A continuous time unit ramp function R of t, a small r of t, my dear students here. Small r of t. Okay, is that the function which starts at t is equal to 0, the function which starts at t is equal to 0 and increases linearly with the time. Increases linearly with the time. As time is increases and linearly correspondingly the r of t is also increases. Means the mathematical expression or functional representation r of t is equal to t for t is greater than or equal to 0 and 0 for t is less than 0. See, r of t is equal to t for t is greater than or equal to 0 and 0 for t is less than 0. And the relation between the ramp and the step function, you can see r of t is equal to t into mu of t. Why we are taking the mu of t? Here also we are taking only the positive values. For negative values is all the zeros. Only when it is a shifting, we will get the values in the negative. Shifting in the right side and shifting the right side means there is no any values in the left hand side. Only when there is an advanced function, we are shifting towards the left side, there is a values in the negative. Okay. But actually the definition saying that only for the positive values the R of t is equal to t into mu of t, the relation. T into mu of t. Or you can see the R, the unit ramp function has unit slope. It is a signal whose amplitude varies linearly. You see, linear means like this. See, as I am taking the t is equal to 0, the R of t is a 0 here. At t is equal to 1, the value is 1 here. And t is equal to 2, the value is a 2. R of t is also the 2. And t is equal to 3, R of 3 is also the 3. And t is equal to 4, R of t is also the 4. So slowly it is a join all the points, you get the linear function. Okay, my dear students. Here, the unit ramp function has unit slope. It is a signal whose amplitude varies linearly. It can be obtained by integrating the unit step function. The R of t is equal to integral mu of t dt. Mu of t dt. What is a mu of t? Is a 1. 1 for the values of 0 to infinite. Okay. 1 into dt. What is a 1 into dt? Is a t. That is nothing but R of t. R of t is equal to the t function. But t is greater than or equal to 0. For t is greater than or equal to 0, the mu of t value is a 1. So integral 1 into dt with respect to applying the t, the integration of constant, we get the t. Or mu of t is equal to d by dt of R of t. If it is an integral means definitely you can apply the derivative. In reverse is a derivative function. R of t in terms of mu of t is integral. Mu of t in terms of R of t is a derivative. D by dt of R of t. That is a relation between of a step and ramp function. Okay, my dear students. Now, the delayed unit ramp signal, whatever we are saying that is a delayed we can use means shifting towards the right side only. Advanced if we are using shifting towards left side. How many samples it is a shifting here? A samples. A is a variable. You can keep the A as 1, 2, 3 and so on, whatever it is. So R of t minus A is equal to, actually it is a t. Now whatever the function is there in the parenthesis here, the t, that only we are taking here. So what is the parenthesis in the R of t minus A? It is a t minus A for t is greater than or equal to A, and 0 for t is less than A. And in the delay function also, the relation between of step and the ramp is R of t minus A is equal to whatever it is multiplied the t into mu of t. Now the t is replaced with the t minus A, mu of t minus A. Okay, shifting A samples, A number of samples. Now see the graphical representation here. What is a graphical representation? Continuous time function, the graphical representation of R of t and R of t minus A. The first one is R of t. The t is increases, R of t is also increases, getting the slope. Correspondingly is increases. It is a linear function. The ramp is a linear signal. Don't say it is a linear system. Linear system is different and a linear signal is different, my dear students. This is only the signal. Linear signal. What is the example of the linear signal means? You can say that it is a ramp signal is a linear signal. What is a linear system? Don't say it is a ramp. That is another topic we can discuss in later. Now here, the shifting of A samples. A samples means it is A from the 0. It is shifted towards the right side because it is a delay function. A samples is shifted, and whatever the slope is like that, the slope is will get from the A. Okay, my dear students. Now You see the same as the discrete function also. The discrete time unit ramp sequence. Continuous R of t, discrete means R of n. Where whatever the t is there, replace with the n only. R of n is equal to n. For n is greater than or equal to 0. R of n is equal to 0 for n is less than the 0. And the relation between of the step and the ramp is R of n is equal to n into mu of n. Previously it is a t into mu of t. Now it is n into mu of n. And shifted version of the discrete time unit ramp sequence is R of n minus k. K is a sample I am taking here for the discrete. A is the sample I am taking for the continuous. Same, the equation, the functional representation R of n minus k is equal to n minus k for n is greater than or equal to k. R of n minus k is equal to n minus k into mu of n minus k. Relation between of step and the ramp. And that relation is ramp R of t is equal to integral of t into mu of t. Integral mu of t into dt. Okay. And otherwise, mu of t is equal to the derivative of the rate of change of the ramp function with respect to the time. D by dt of R of t. Okay. Now the graphical representation showing here R of n. Let the R of n is like this. Okay. At 0 is a 0, minus 1 is a 0, minus 2 is a 0, minus 3 is a 0. At 1, the value is 1. Okay, ramp function. See here, it is slowly, it is increases, and correspondingly the n is also increases. N is equal to 0 is a 0, n is equal to 1, the 1, n is equal to 2, the 2, n is equal to 3 is a 3, n is equal to 4 is a 4, and so on. The negative values is a zeros. Okay, my dear students. Negative values is a zeros. See, it's a shifting of two samples. The example is showing that is R of n minus 2. How many samples are shifted towards the right side? Because it is a minus means right side only. It is a delay function. The two samples. Two samples means the 0 is a 0 here, and it is shifted towards the right side as 1, and the 2. Taking that the value is started from the 2. Whatever the value is started from here, it is a 0. That is at 2 now. 3 is 1, 4 is 2, 5 is 3, and 6 is 4. See how many samples is getting here? The 6. Previously it is a 4. At n is equal to 4, we got the 4. Now at n is equal to 6, we got the value of R of n minus 2 is a 4. So means the total samples starting from n is equal to 0 to the n is equal to 4, these 4 samples is shifted towards the right side with the 2 samples. What is the 2 samples delay? 1 and 2. Okay, the 0 value is here, and 1 value is shifted towards here, and 3 value is shifted towards here, and the 4 value is shifted, and 5 value is shifted, and 6 values will get n minus 2. Coming to the n minus 1, let us see. I will show that what is the n minus now the ramp function. Ramp shows like this as a continuous R of t for t values varies from 0 to 1, linear function. Or otherwise, discrete is a continuous time, and in the discrete R of n, for 0, the value is a 0. For 1, the value is 1 at discrete functions. 2, the value is a 2, means the magnitude is 2. Okay. And for 3, n value, the magnitude is 3, and 4, the magnitude is a 4. And n, and so on here. Okay. These are two representing of continuous and the discrete. So now I am shifting towards the right side. Shifting value mu of, not the mu, r of t minus 1. Only one sample I am shifting. 0. At 1 it starts. Okay, the value here it is a 0. Means it is not the linear function. And from 1 it is a value changes to t. Suppose the two samples shifted for the ramp function are of t minus 2. The 0 is a 0 and 1 is also 0 and 2, now it starts from at the 2. The value is 1. Okay. Like this, the continuous time function shifting towards the right side. If suppose the advanced function means advanced is shifting towards left side. Okay, advanced function. These two are delay functions. What is the advanced function here? Suppose if I am taking the 0 here, r of t plus 1 is advanced. Means from minus 1 it is linearly increases. Linearly increases at minus 1. Okay, and similar way r of t plus 2 plus means again it starts from the minus 2, minus 1, the 0. Now the linear function is like this. So at minus 2 is a 0, minus 1 it is increases, at 0 it is increases, and so on. The advanced function. The similar fashion for the discrete time function also, the advanced and the delay, and this is a delay functions. Delay of ramp signals examples, and this is advanced. Now coming to the discrete time function. Same the discrete time function at specific intervals only, 0, 1, 2, 3 and 4. Now I am taking a ramp function like this with the shifting of one sample or of n minus 1. Means the 0 is a 0. Why it is a 0? Whatever the minus 1 here, the minus 1 is a 0 now. The minus 1 is shifted at the 0 and the 0 value is shifted for the 1 and 1 value is shifted towards 2. What is the value of 1 here? It is a 1. That will get at the 2. 1 and 3 means what is the 3? What is the one sample is shifted? The 3, the 2 value whatever we have in the r of n and is getting at the 3. 2 and for 4, 3 and for 5 is a 4, not the 4, 5 and so on. Is r of n minus 1. Only one sample is shifted. One sample means whatever the value is here, it is a shifted, that is a 0. And whatever the value at n is equal to 0, the value is getting at the n is equal to 1. 1 is also 0. And the value of 1 at n is equal to 1, you get at the 2. And the value of n is equal to 2, you'll get at the n is equal to 3. And the value of n is equal to 3, it will get at the n is equal to 4. And the value of n is equal to 4, it will get at the n is equal to 5. Means one sample is shifted. If it is a 2 samples is shifted, 2 samples shifted means r of n minus 2. R of n minus 2. So 0 is a 0 and 1 is also 0. Now the 2 is also 0. Because see, is a one sample. For this reference, it is a one sample. For this reference, it is a one sample only. Comparing of r of n minus 1, r of n minus 2 is a one sample. Comparing r of n, The R of n minus 2 is a 2 samples. So at the 3, the value is 1. Means it 0, whatever the value at the 0 will get at 2, starts from the 2, because it is a shifting of 2 samples. For 4, it's a 2. For 5, it is a 3. And for 6, you'll get the 4. You now see the last sample will get at the n is equal to 6. But here, what n is equal to 4. The 2 samples right side. And comparing here, the last sample is at n is equal to 5. Comparing these two, only one sample is shifted. Comparing these two, the only one sample. And comparing of R of n and R of n minus 2 is a shifting of 2 samples. And these two as a delay functions. Delay. And how the advanced function of the discrete time function look like. So for this same example, if I am taking R of n plus 1, R of n plus 1, okay, minus 2 is a 0, minus 1 is also 0, because shifting towards the right side. The 0 value is getting at the minus 1, 1 value is getting at the 0, and 2 value is getting at the 1, and the 3 value is getting at the 2, and 4 value is getting at the 3. Means towards the left side. So at the 0, now the value is 1. At 1, the value is a 2. And at the 2, the value is a 3. And at the 3, the value is a 4. Now see, and now at the 4 is the value is a 0, because there is no any value in the 5. See one sample, the 4, the value R of n plus 1 is equal to 4, we'll get at the n is equal to 3 only. N is equal to 3, means shifting towards the left side is advanced function. Advanced function. Okay. The same thing, if I am taking that as R of n plus 2, R of n plus 2. If R of n plus 2, n values, take it as R of n plus 2, means 2 samples. 2 samples means it starts from the minus 2 itself. Minus 3 is a 0, minus 2 is a 0. At minus 1, the value is 1. At 0, the value is a 2. At 1, the value is a 3. And at 2, the value is a 4. And 3 is a 0. And 4 is also 0. Means in the right side, the 3 and 4 values becomes the zeros. And for this R of n plus 1, only the 4 is a 0. Means the 2 samples is shifted. 2 samples shifted means it starts from the minus 2 here. Minus 2 is a 0, minus 1 is a 1, and 0 is a 2, 1 is a 3, and 2 is a 4. But here, minus 1 is a 0, and 0 is a 1, 1 is 2, and 2 is equal to 3, and 3 is equal to 4. Advanced functions. Now we got some clarity how the ramp function is shifted. Ramp means slowly it is increasing. See, this is also the ramp like this. And this is a ramp like this, shifting of one sample. And you can draw a signal like this, it is a ramp signal. And here it is a ramp signal. And this one is also ramp. Okay, discrete. Time is only the discrete, amplitude is a continuous. But continuous means both the time and amplitude is continuous, and discrete means only the time is discrete, amplitude is a continuous. You see here also is a ramp signal. But at particular specific intervals of time only, specific intervals of time. Okay, my dear students. Now then, you go for the next topic, Now the next topic and next one, unit parabolic function. Unit parabolic function. See, in the continuous time, unit parabolic function, P of t, parabolic P of t, ramp R of t, step mu of t. Step mu of t. P of t is equal to, you see here, the continuous time unit parabolic function P of t, also called unit acceleration signal. Unit acceleration signal starts at t is equal to 0 and is defined as P of t is equal to t square by 2 for t greater than or equal to 0 and 0 for t less than the 0. The next level, acceleration. So why they are calling it as acceleration? Let us see here. See, displacement, the rate of change of displacement means velocity. The rate of change of velocity is acceleration. Okay, dx by dt, nothing but velocity. dv by dt, nothing but acceleration. Okay, see, in the previously, r of t is equal to t into mu of t. Now, that r of t, now assuming as a velocity, now apply a derivative for that one, derivative of that one. See, the p of t is equal to t square by 2 into mu of t. How we got this function? Now let us take here, we can understood. So previously the relation between of ramp and step function is t into mu of t. Okay, otherwise r of t is equal to integral of mu of t dt. That is equal to, what is the mu of t? From 0 to infinite, the relation here, the minus infinite to infinite. Actually, from 0 to infinite, the mu of t value is 1 into dt. Okay, why? The mu of t is equal to 1 for t is greater than or equal to 0 and 0 for t is less than 0. We know this one. This is a function. So from minus infinite to infinite, the negative values is a 0 and for positive values, the mu of t is equal to 1 is equal to, what is a 1 integral with respect to? That is a t. Okay, the t on the r of t is equal to the t for these values. Nothing but the t is greater than or equal to 0 and 0 for t is less than 0. This is the equation we got for r of t related with mu of t. Now coming to that, r of t as considered as a velocity, the displacement x, the velocity is dx by dt, and acceleration is dv by dt or d square x by dt. d square x by dt, the second derivative. Now the parabolic function, the p of t, I am writing it as a p of t is equal to t square by 2 mu of t, the step function. T square by 2 of step function. How it is the integral of t mu of t, integral of t mu of t. So the p of t is equal to integral minus infinite to infinite, that I am taking the r of t into dt. Okay, the velocity And if I am taking this r of t as t into mu of t, let us here the t into mu of t on the integral minus infinite to infinite t mu of t dt is a function. The t mu of t dt. What is a mu of t? According to this equation, the integral is changes from 0 to infinite. Okay. 0 to infinite t into dt. Okay, my dear students. T into dt. I am substituting the mu of t is equal to 1 in the range of 0 to infinite. The remaining minus infinite to the 0, the value is a 0, 1. What is the integral of t into dt? The t is t power n plus 1 by n plus 1. What is the n here? 1 only. So t square by 2, t square by 2, 1 plus 1 by 1 plus 1. And with the range of 0 to infinite, we can write as a p of t is equal to t square by 2 for t is greater than or equal to 0 and for t is less than the 0. Okay, this is a function t square by 2. Or otherwise, if t is greater than or equal to 0, is the value is a 1 and t is less than, the value is a 0. So finally, you can write as a p of t is equal to t square by 2, and this range we know that is a mu of t range into 1 mu of t. Okay, now we got this function. Understood, my dear students, how we got that parabolic function, parabolic function, and is a ramp function. Okay, r of t is equal to t into mu of t, the relation between of the step and the ramp, and parabolic, the relation between the step and the parabolic is t square by 2 mu of t. Or the parabolic and with the ramp is t into r of t. Okay, t into r of t. That is nothing but. Now come again. You see here. That is the way we got the p of t, the t square by 2 mu of t. And shifted version of unit parabolic sequence, the p of t minus a. Whatever the t is replaced of the t minus a, the t minus a whole square by 2 for t is greater than or equal to a, and the 0 for t is less than a. And same, the equation relation between of the step and the ramp, p of t minus a is equal to t minus a whole square by 2 mu of t minus a. Wherever the t is there, that is a t minus a. Minus means a delay function. You see the graphical representation of the parabolic. Parabolic from 0, slowly it is decreases. Not it is a ramp, parabolic. Shifting operation. From a it starts and slowly it is increases. P of t minus a. That a is 1, it starts from the 1. If a is 2, it starts from the 2. If a is 3, it starts from the 3. Okay, my dear students. This is a graphical representation of the p of t and the p of t minus a in the continuous time function. This is a continuous. The parabolic function can be obtained by integrating the unit ramp. See here, there is a relation is there. For ramp, p of t is integral r of t dt. For step, there is a 2 integrals. Means second derivative if it is a reversed. The reverse, it is a ramp and the derivative is mu of t is equal to t by dt of r of t, and p of t is equal to d square by dt of dt square of the mu of t. The second derivative here. Or integral means p of t, the double integral of mu of t, or single integral of the ramp function. That is a t dt t square by 2 for t is greater than or equal to 0. Okay, my dear students. Now coming to the same thing it shows in the discrete time function. See, the ramp function is a derivative of the parabolic. R of t is equal to d by dt of p of t, or mu of t is equal to d square by dt square of the p of t. So d by dt of x of t, nothing but velocity here. And d square by dt is the acceleration. So p of t, acceleration if I'm taking. The discrete time function, the t is variable in the continuous. Here the n is a variable in the discrete function. The p of n is equal to n square by 2 for n is greater than or equal to 0. And 0 for n is less than 0. P of n is equal to n square by 2 mu of n. And shifting version of the discrete unit parabolic sequence, the p of n minus k is equal to n minus k whole square by 2 for n is greater than or equal to k. And 0 for n is less than k. The p of n minus k is equal to n minus k whole square by 2 mu of n minus k. Only the change as a variable. Here the continuous is a t, for discrete is a n. The shifting operation is a, t minus a, for in the discrete n minus k. Show the graphical representation. It is not linear, slowly it is increases. Slowly it is increases, not correspondingly it is increases, slowly it is increases as like a curve, parabolic. And p of n minus 3. N minus 3 means totally shifted 3 samples. It starts at the 0. Now that 0 at n is equal to 0, the value is a 0 of p of n. It will get at the n is equal to 3 here. Means 3 samples is shifted. P of n minus 3. From 3 is a 0, 4 is a, slowly it is increases, 5 it is a value increases, 6 increases, 7 it is a increases. Follow my dear students. Like that, we'll get the shifting operation of n samples, n minus 3 samples, 4 samples, 5 samples, whatever it is. Okay. Now it's completed of elementary signals of 3. We discussed step function, we discussed ramp function, and we discussed the parabolic function, the relation between of step ramp and the ramp and parabolic, and the parabolic and the step also. And tomorrow's class will continue the remaining topics. Okay, my dear students. If you have any doubts, please arise. Thank you, and thank you one and all.